Hello everyone, and welcome to Biopedia. Today we're going to discuss the various forms of skeletons animals have. We'll be distinguishing between endoskeletons, exoskeletons, and hydrostatic skeletons. First of all, we have the type that would be most familiar to us as a species, the endoskeleton. These are inside the body, and a lot of animals have them. Such animals need something supporting them on the inside of their bodies to stop outside pressures causing them to change shape and to stop the animal's mass from making it collapse. The skeleton is not deformed, and this skeleton is responsible for shielding the internal organs from harm. It's often constructed from bone, as you would find in, for example, humans. However, cartilage is also used in animals such as sharks. Skeletal muscles are attached to the bones via tendons and allow them to move position. Part of this endoskeleton is the vertebral column or backbone. This is a movable column which goes down the length of an animal's body and protects the spinal cord. The spinal cord itself comprises part of the central nervous system and is surrounded by vertebrae, which are a series of bones with cartilage between them. Having a backbone is what distinguishes vertebrates from non-vertebrate animals with a bilateral body plan. Animals in this latter category include starfish, mollusks, and annelids. Then there's exoskeletons. These are found on the outside of the body. They help the animal move and stop animals such as insects from becoming too dry. In some cases, the exoskeleton would prevent the animal from growing because it does not change size while the animal does as it matures. In such cases, the animal would need to molt. There is a third option besides endoskeleton and exoskeleton for less complex animals, with an example of such an animal being the earthworm. These animals have a cavity filled with liquid on the inside which can move and has muscles around it. The muscles around this cavity contract and relax in order to pull parts of the animal in the direction it's trying to move. In the case of the earthworm, there are also bristles which prevent movement when gripping onto a surface and permitting movement when they are released. Hydrostatic skeletons can also be divided into whether there is a hard element or not. An example of the latter case would be the legs of spiders, so they do have some form of hydrostatic skeleton even though they also have an exoskeleton as we previously discussed. In this case, there are no extensor muscles, so extending legs with those muscles would not be possible for obvious reasons. Jumping spiders, or Psittacus pubescens to give them their Latin name, jump onto their targets using their two back legs. These extend due to hydraulic pressure using blood pressure. So there is a hydraulic or hydrostatic element even in spiders which have exoskeletons. That's it for today's episode. As always, thank you all for listening. Feel free to get in touch at the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.